Welcome to this explainer. Today we're breaking down a really fascinating and honestly highly speculative cosmological framework proposed by N. Dinesh Kumar. It's called the Beyond-Light Rotational Spacetime Theory, or BLRST for short. This framework is going to force us to look at the night sky and the unseen physics governing it from a completely different angle. We're rethinking the life cycles of galaxies, the actual necessity of dark matter, and the ultimate fate of matter in the entire universe. Okay, let's just dive right into this by asking a question that totally challenges the very foundation of modern astrophysics. For decades, we've been taught to think of black holes as these infinite, bottomless pits in space, right? Points of no return where matter is just crushed out of existence. But what if we completely ditch that idea? What if a black hole isn't actually a hole in the classical sense at all? Traditionally, standard cosmology sees black holes as infinitely empty, singular vacuum points. At the center, that infamous singularity, our current understanding of physics essentially breaks down. But BLRST proposes a pretty radical alternative view. It suggests that black holes are actually ultra-dense, highly organized rotational compression structures. So instead of matter being destroyed in a singularity, it gets transformed into this highly compressed relativistic state. Section 1. The Cosmic Rotation Mystery. To understand why the speculative theory was even developed in the first place, we've got to look at a massive cosmic mystery recently uncovered by our most advanced telescopes. Observations from the James Webb Space Telescope have seriously thrown a wrench into standard galactic timelines. We are seeing massive galaxies in the very early universe, like the anomaly known as XMM-ZNV 12075, that just appear unexpectedly mature. And even more puzzling, some of these early systems possess much weaker rotational structures than our standard formation models predict. They literally look like they've already lived a full, chaotic life, way earlier than they ever should have. So, the BLRST framework steps up to reinterpret these exact anomalies. It argues that rotation isn't just some secondary byproduct of matter falling together. Nope, rotation is a primary structural organizer of the cosmos. According to this theory, rotational dynamics dictate gravity. They alter local space-time behavior, and they drive the long-term evolutionary cycles of entire galaxies. Section 2. Rethinking the black hole. Let's zoom in from the macro scale of those early massive galaxies all the way down to the micro scale of a black hole's core. We really need to see exactly how this theory changes our understanding of the famous event horizon. Contrasting the standard singularity model with the BLRST view is super eye-opening. Standard physics sees the event horizon as a point of infinite density where physics just falls apart. But BLRST illustrates the event horizon not as a physical wall or some edge of nothingness, but rather as an observational and dynamical boundary. It marks a zone of extreme rotational space-time transition, where electromagnetic observation simply becomes impossible because of how intensely space-time is being dragged and curved by rotation. When looking at the internal layered structure proposed by the theory, things get wild. The outer layers of a black hole rotate relatively slowly, but as you move deeper into the inner layers, everything changes drastically. Density, rotational velocity, gravitational fields, and magnetic fields all massively spike as you approach the ultra-compressed core region. So here is the crucial point. Matter isn't actually destroyed here. Instead, the intense gravitational inward collapse is perfectly balanced by outward centrifugal forces, which the theory calls rotational stabilization. This equilibrium pushes matter into an ultra-relativistic, beyond-light rotational state. Now, it's not that things are moving linearly faster than light, but rather the local space-time is so profoundly modified by rotational density that traditional electromagnetic observation just utterly fails. Section 3. The Galactic Recycling Center. This brings us to a really monumental question. If matter isn't destroyed in a black hole, but just highly compressed, where on Earth does it go, and how does it influence the wider galaxy over billions of years? Well, imagine a vast initial cloud of matter. As gravitational attraction pulls the cloud together, its compression and spin increase. It enters a high rotational state until it eventually hits what BLRST calls an instability threshold. When this critical limit is finally breached, we see a massive energetic release. Matter is radically redistributed outward in the form of intense plasma jets, high-energy particles, and aura-like outflows. BLRST formalizes this continuous cosmic recycling program into 4 distinct steps. First, we start with initial matter, labeled M1. This matter undergoes intense rotational compression, or RC, inside a black hole. Eventually, instability leads to energetic redistribution, or ER, violently ejecting plasma and energy outward. Ultimately, this dispersed material cools and gathers to form a completely new, transformed matter state, labeled M2. The takeaway here? Matter is never lost. It just changes form.
This means galaxies actually evolve cyclically, and the theory proposes three speculative pathways for this regeneration. First, instability-driven blasts that violently redistribute matter to birth entirely new systems, acting almost like localized Big Bangs. Second, black hole mergers, where two galaxies collide to create larger, more complex rotational systems. And third, weak rotational collisions. In this scenario, black holes collide without forming a stable core, resulting in a galaxy with a regular, weak momentum. And you know what? This specific pathway might perfectly explain the mature, yet weakly rotating anomalies like galaxy XMM VIDE 2075 that the James Webb Space Telescope keeps finding.
Section 4. An alternative to dark matter. Beyond just redefining black holes and mapping galaxy formation, the author suggests this rotational framework could also step up to address one of the biggest, most stubborn puzzles in all of standard cosmology. We know from decades of observation that stars at the outer edges of galaxies rotate way faster than the visible mass of the galaxy alone can explain. In a standard Newtonian model, those outer stars should literally be flying off into the void. To make the math work, standard physics relies heavily on massive, unseen dark matter halos that surround galaxies and hold them together. However, BLRST proposes a radical alternative explanation for the observed speeds of these stars. While standard models predict speeds dropping off too fast without dark matter, the BLRST framework argues something totally different. It claims that extended rotational space-time layering and compression field interactions organically create the stability we see, potentially reducing or completely eliminating the need to invent invisible dark matter in the first place. A real game-changer if true. Section 5. Speculation or science. As absolutely captivating as this vision of a cosmic recycling center is, and as neatly as it ties together black holes and galactic rotation, it is absolutely crucial that we step back. We must impartially evaluate the current scientific standing of this framework. A scientific theory is only as good as its ability to be tested and potentially falsified. The good news is, BLRST does offer testable predictions. It predicts we should find undermassive or structurally weak central black holes in early, weakly rotating galaxies. It also predicts layered space-time behaviors that correlate directly with rotation anomalies. This means future high-resolution telescope data could either powerfully support these ideas or completely invalidate them. The author himself, N. Dinesh Kumar, explicitly provides a disclaimer in his work, acknowledging the theory's current limits. He notes that BLRST currently lacks complete mathematical proofs, robust numerical simulations, and direct observational evidence. He cements its status right now as a purely speculative hypothesis, an exploratory concept, rather than accepted mainstream physics. It's an idea, not established fact. Yet, even as an unverified, speculative concept, BLRST is just incredibly thought-provoking. It forces us to look at the night sky differently. It paints a picture not of linear decay into singular voids, but of a dynamic, churning cosmic engine. It leaves us to wonder, if galaxies truly are born, compressed, and endlessly reborn in a massive cosmic blender, where exactly does our own Milky Way currently sit in that grand eternal cycle?